Good day everyone. Today I'm going to tackle you what is the exogenous pathway. First, let me show you the illustration of an exogenous pathway. This is what it looks like. So now I'm going to tackle you what is an exogenous pathway. Here's what happens in exogenous pathway. First, our dietary triglycerides and cholesterol will be absorbed in our small intestine. It will be absorbed in our small intestine. Then after the absorption that happened in the small intestine, the triglycerides and the cholesterol becomes a macromolecule or a so-called lipoprotein or a chylomicrons. It will be transformed into a chylomicron. Chylomicrons are made to be a water insoluble so that it can prevent itself in entering the circulation. For that reason, the chylomicrons will proceed to the lymph, then it will be drained to the thoracic duct. After that process, it will now proceed to enter in the bloodstream or in capillary. The chylomicron will have a customized apolipoprotein, which will ease the circulation. The apolipoprotein's purpose is to help circulate of water-insoluble lipids. Then if it enters the circulation, it will be bound into B48, which is the apolipoprotein. It will activate the lipoprotein lipase that is present in the vascular endothelium. The activated LPL or the lipoprotein lipase is now responsible for the esterification of fats, which is also called free fatty acids, which will later convert into the adipose tissue. It will decline the lipid in the metabolized form so that it can use the raw material. When ApoB will be activated, it will interact with the lipoprotein lipase and will cause its activation. After the activation, there will be what we call the esterification. Then it will create a cleavage or breaking down of chylomicron. After the breaking down or cleaving of chylomicrons, fatty acid will be produced and or will be used to form an energy. Now, the remnants will have a remnant receptor or ApoE to bind with the liver. The liver will now produce the HDL. That's it for exogenous pathway. And now let me tackle to you what is the endogenous pathway. The endogenous pathway starts with our liver. Our liver will use the fatty acid to synthesize the TAG or the storage form of fats and the VLDL or the very low density lipoprotein. ApoE, ApoC, ApoB100 is now attached to the circulation, and now the LPL will convert your VLDL or the very low density lipoprotein. The presence of APO will signal the LPL to convert the VLDL to become IDL. The LDL particles contain a core of cholesterol esters and a smaller amount of triglyceride. The LDL is internalized by hepatic and non-hepatic tissues. There are two pathways. In the liver, the LDL is converted into bile acids and secreted into the intestines. In the non-hepatic tissues, the LDL is used in hormone production, cell membrane synthesis, or stored. The LDL is also taken by the macrophages and other cells, which can lead to excess accumulation and formation of foam cells, which are important in plaque formation. How to convert into IDL? The IDL happens when we remove the ApoC. The ApoC is eliminated. It will become an IDL, and then it will enter the liver. 70% of the LDL will go to the liver to become part of the bile, while 30% will go to the cell membrane, the steroidogenesis, and excessive part will become an atheroma, or what we call the blockage inside the blood vessel, and can form atherosclerosis. Now let's proceed to the atherosclerosis formation. First, let's figure out what atherosclerosis means. Well, atherosclerosis is caused by the lipid plaques that affects and narrows the arteries. Well, atherosclerosis plaque formation involves 5 steps. First is the low-density lipoprotein accumulation in the intima. Second is the oxidation of LDL. Third is recruitment of monocytes to macrophages. 4 is uptake of oxidized LDL by macrophage scavenger receptor and transformation of macrophage into foam cells. 5 is formation of fibrous cap containing smooth muscle cells, which permits stabilization of plaque. Well, the process goes like this. This is an illustration of the formation of atherosclerosis. Now let's figure it out one by one. The formation of atherosclerosis begins when the endothelial cells of the arterial wall become damaged, which can be caused by hypertension, smoking, hyperglycemia, and hypocholesterolemia, or an increased LDL in the blood. The endothelial cell damage increases the permeability of the arterial wall, allowing LDL to enter in the tunica media. It enters in the tunica media. The WBC, which is specified as the monocyte, usually moves freely to the blood vessels and do not attach to the endothelial cells. However, when endothelial cells are exposed to irritating stimuli or damage, it will expose adhesion protein molecule that can attract and capture nearby WBC. This is how the WBC attaches. It attaches to the endothelial cells with this adhesion protein molecule. The WBC or the white blood cells will undergo morphological changes that allows them to resize and get inside the vessel. This action is called the diapedesis. The diapedesis happens in between the endothelial cells so that the WBC can enter into the vessel. Now, the WBC will produce free radicals, and when these free radicals come into contact with LDL, oxidation occurs. The oxidized LDL particles are effective in attracting and activating WBC. The WBC that engulfs the modified LDL particles, which stimulates them to produce even more oxygen-free radicals. This is how the free radical works when released to WBC. Free radicals produce the LDL, then the oxidized LDL will now later be absorbed by the WBC. The area of endothelial damage will lead to an accumulation of modified LDL particles and migrating WBC. In these instances, there will be a positive feedback situation, which will bring more modified LDL and more immune cells. The macrophages in tunica intima starts to engulf modified LDL particles. This leads to foam cells. A foam cell is saturated with LDL particles, and the excessive amount of lipid in the cell gives the cytoplasm a foamy appearance. That's how it works. The WBC will absorb the LDL and the free radicals, which now later on build a foam formation and make a foamy appearance. Well, naturally, the foam cells will ultimately die and release their contents. It will die and release its contents. Which are then quickly engulfed by other nearly WBC. So, kumbaga, kapag may namatay na foam cell, other WBC will take over the released LDL. Eventually, the accumulating lipid from the process, which are the fragments of dead cells, creates an area with a lipid core that begins to form a plaque. The released lipid form will create a plaque. Then endothelial cell will cover the plaque. For the reason, the plaque will accumulate calcium salts and more dead cells over time, and it will eventually harden. The plaque, will create a calcium salt and more lipids, which will later on will be hardened. This plaque is what we now call the atherosclerosis. If the endothelial cells over the plaque are compromised, blood clots can form on the vessel wall. This is the endothelial cells. When it is compromised, it will harden and can form in a blood clot. The blood clot will now be called as thrombus. Usually, the healthy endothelial cells normally express inhibitors of clotting, but now, since they are damaged, they no longer do this. Over time, the ruptured areas of plaque may create a situation where an area of plaque may jut out into the vessel of lumen. A clot that forms and attaches to the wall is what we call a thrombus. If the clot breaks loose, it floats downstream to even smaller vessels. That's how the formation of atherosclerosis works.